Hello and welcome to some more interesting weird POV effect experiments. So just to recap, what you're seeing here is not really a well-defined cube. There are no well-defined lines on the screen. You're just seeing lines of pixels changing from black to white or white to black. And if you pause the video at any point during this section here, you'll see there's nothing there. There's no cube visible. It's just a patch of random black and white dots. But as soon as you play the video again, the cube becomes clearly visible. And you can look at my earlier videos for more information about how that works and some more examples of it. But in this video I wanted to have a look more at the role of the different colours. So this came up in the last video I made about lots of different colours on the screen. So in this case, the version of the software I've got here now I've updated, so I can draw the cube in red. It's a pure red, pure green, pure blue, black, which unsurprisingly doesn't do anything, and pure white. And so we can see, as you saw just now, the black against white works nicely. You can see the cube quite clearly. If I go on to red, the red works pretty well as well. They all work pretty well on their own, so if I spin through these quickly, you can see the green. I think you can see the green fairly clearly as well. And the blue, not quite as good. It still works pretty well in this mode. This blue looks darker to me. I don't know, maybe it's just my screen, but I think the blue in general seems a bit darker. Although, looking at the hue, saturation and luminance values here, all the pure colours have the similar luminance. But now if I start mixing the colours together, we'll see some different effects. So I'll go back to the white. If I start doing red over the top of the white, that instantly becomes a bit less clear, I think. So now we've got a mixture of red, white, black and sort of cyan colour from where the red and the white combine. That's not quite so clear. If I add in the green, it becomes a bit clearer again. Not really sure why, but green seems to work pretty well. And if I switch to blue now, so the cube is being drawn in blue over the top of all the other colours, that's barely visible at all. So I think this is quite surprising. I wasn't expecting to see that when I first tried this, but you can see there is a cube moving there, but it's very faint. Of course, if I switch to black, then you see nothing at all, because literally nothing is changing now. There's drawing black in this XOR mode over the top of another colour just doesn't change the other colour at all. And then switching to white again, you get quite a nice clear effect. You've got full luminance now and full colour on all three channels. So that's a nice clear effect. So yeah, it's kind of interesting. I'm not sure why the blue should be so different. Let's try if we just do green and then blue over the top. Yeah, still very faint. So the blue just doesn't have as much effect on the colours that are there already as the other colours do. So I guess that's why the blue has a much smaller effect. So yeah, a few people suggested that it was a luminance that was the key, and that a more luminant colour would have a stronger effect, which does seem to partly be true in that the white has the strongest effect, which is the brightest colour in terms of luminance. But as you can see here on the sliders, the red, green and blue all have the same luminance according to this HSL model, and yet they have very different effects in terms of the visibility of this weird effect. So yeah, it's interesting stuff. I can actually let's see if I go back to just plain white. I can vary the luminance. You can see lots of various shades of grey coming in now as I turn the luminance down, and we get the it's now drawing in a much darker shade, but it's still quite visible even though it's quite dark now. It's getting less visible as you turn it right down, and obviously black you get no effect at all. And if I change the hue, Can't change these in quite the same way as you can the red, green and blue, but there you go. So now I've got a sort of darkish green, that's very visible, no problem at all. We go up to more of a purple blue colour, it's still quite visible in this case. If I make the blue more saturated, well, we get more colours and more range of colours on the screen, it's actually becomes a bit less visible to me. So it's all very curious. I'm sure somebody must have researched all this and knows exactly why this happens, but yeah, drop me a comment if you know what's going on, or if there's any sort of research that explains this in more detail. I'd be very interested to see it. So the next thing to have a look at is just the general complexity of the different shapes and how that affects the visibility of this effect. So the cube is very simple shape, obviously, and seems very easy to track in most cases, despite the effect of the colours that we've just been looking at. In the very sort of high contrast case like this, the cube is very easy to see. So let's try a more complicated shape and see how that affects things. So I've got a few different shapes in here now. I can switch to this Coriolis space station, which some of you may remember from the famous 80s video game Elite. And this is similar to the cube, but obviously you've got more geometry, more edges, more vertices. And you'll see as that turn off the background erase, it's a little bit harder to see. It's you can still see it, it's still there. You can sort of make out the rectangular entrance to the space station as it moves around. But I think it's definitely harder to see than the plain cube, and I guess that's just because your eyes are having to work a lot harder to see all the changes, or to process all the changes from one frame to the next. So let's try another one. I've got the famous Cobra spaceship also from Elite here. Make that a bit bigger. So this again is a more complex shape. If you're familiar with what shape it is, you might be able to see it a bit more clearly, I guess. I'll turn off the background erase so that you can see what it actually looks like. So it's just a kind of triangular, flat, pointy spaceship thing. But with the background erase turned off, it becomes a little bit harder to see. Still not too bad. So now let's move on to something else. We've got this T-mug shape. So this is a very simple bit of 3D modelling I've done in Blender. I'm not an artist of any kind, obviously. But hopefully you can see roughly what that shape is. I'll turn off the background erase so you can get a better look. I'll zoom that back out a bit. So again, it's pretty clear to see when the background erase is off and your eyes are able to see the actual contrasting lines and curves of the shape. But when I switch off the background erase and you're now relying only on your sort of change detection to see the shape, it becomes much harder to see, which is kind of interesting effect. So now, staying with Blender, let's have a look at Suzanne. So Suzanne, if I turn off the background erase again, this is a famous sort of monkey head shape that is built into Blender. Probably quite hard to see. I'll put a separate image on screen so you can see what it should look like. So it's quite hard to make out what this is at all. You can sort of make out the two ears and the kind of long chin sticking down there. If I turn off the background erase, this becomes almost impossible to see. I think, you know, if you only saw it in this format, you'd struggle to pick out what you were seeing here. Which again is just, I think, because there are just so many pixels changing from one frame to the next. I can actually click on this one frame and we'll have a look. So the static image now, if I just click one frame, you can see it advancing by one frame at a time. But really, when you can see a rough shape of what pixels have changed, but you can't make out any detail. So if I switch back to the cube, it's very easy to see the let me mess the background up a little bit first. And zoom out. So now if I go back to the one frame, it's quite easy to see. Even if I go one frame at a time, you can see the cube just for a split second. It's fairly clear. But with the Suzanne, nothing like as clear at all. So it really looks like whatever parts of your visual system or your brain are detecting the changes in the pixels, they're getting overwhelmed with this amount of change. Your main kind of visual circuits that detect the shape of things and rely on the contrast between the background and the foreground, like we're seeing here, are pretty good at picking out the shapes. But the kind of the change detection version is obviously much less capable, I guess, or doesn't scale as well, which I guess is why these more complex objects are much harder to follow. And the final one, just to sort of prove the point, really, is this very simple sphere, which I think it's got about 20 lines of longitude going round and 12 lines of latitude. When I turn off the background arrays here, you just see it's just a mess. Like, you can barely see. You can see everything is changing. You can't really make out the lines of longitude and latitude that you could clearly see when the background erase is turned off. Again, I can change the colours, but it doesn't really help. A little bit better perhaps with the green. Blue, again, you can see things changing. There's kind of a rippling effect there. The colours are changing, but I can't make out any lines at all there now, so for some reason the blue doesn't work very well at all. And the white again is probably the best effect, but still very, very scrappy. So this software I'm using to show all these effects is available on GitHub. It's all just a fairly simple Windows app that I've written just for the purpose of these videos, but I've put it on GitHub so you can have a play with it yourself if you like. Just show you quickly, the link here is in the description as well. You can look at all the source code if you want to, if you're into that sort of thing, but if you just want to download the program and play with it, you click on the releases over here, and then you can download the exe file and just run it directly from your downloads folder or wherever. Obviously you do so at your own risk. I can guarantee there's no malware in it when I upload it, but you should always be careful if someone tells you to download something off the internet and run it on your computer. But yeah, have fun. So the next sort of fun effect I wanted to show you was just what happens if the shape overloads itself after a certain amount of time. So this is something you may have seen in the Bad Apple videos I did a couple of weeks ago, is when they played through all the way through twice, the second run of the video completely wipes out everything that was done to the screen in the first run of the video, and you end up in the last few frames with the last few seconds of the Bad Apple video completely erasing everything from the screen, and you get back to a blank screen again, which is expected with the exclusive OR operation. That's what happens. If you do exactly the same operations to each pixel an even number of times, then the pixel gets flipped from black to white and back to white again, back to black again, an equal number of times, and every pixel ends up going back to black how it started. And so you may be wondering, and I was wondering myself, why this doesn't happen while I've been whittering on to the space station here on the screen. Why isn't it overlaying itself and coming back to a black screen? The reason is a little bit mathematical, but it's basically because within the software I'm rotating the object by a small fraction of a radian on each frame, and because radians and the way pi interacts with radians to define a full circle and so on, if I rotate the sphere by say 0.1 radians for every frame, it's never going to come back to a whole multiple of pi radians, so it won't ever get back to quite where it started, and it's doing this in all three axes at the same time. which I think explains why you don't see the space station or whichever object it is sort of erasing itself and coming back to a black screen. So I've added some extra little bit of maths into the code that does that. And if I switch on this integral checkbox here, this now means that the amount by which the space station rotates on each frame is a small specific fraction of a full 2 pi circle, 2 pi radians, and that means after a certain number of frames it will come back and overlay exactly where it was before. So if I erase the background and start it running again, at first everything looks the same. It's just overwriting previous versions of itself and leaving a big mess behind. But after a few seconds you see it starts to erase what's there already, and everything goes back to black, and then it all starts again. So just that small change in the maths to make sure that the rotation amount does add up to a multiple of 2 pi after a fixed number of frames is all you need to make this effect happen. And this effect also works quite nicely if you just do it with 2 colours rather than getting too complicated with lots of different colours. But if I let this build up a bit of mess on the screen here and then just switch to the next colour, you see the blue starts to overlay the green, but after a few frames all the blue that's been drawn will disappear and we'll end up back with the pure green again before the blue starts overwriting it again. So it's all it's kind of expected mathematically, but still seems a little bit surprising to me how cleanly the whole process can undo itself and leave you back with exactly what you started with, even hundreds of frames later. So thanks for watching if you have been. Well done for getting to the end of the video. Drop me a like and a subscribe and a comment and all those things. It really helps provide a good bit of positive feedback for me and for YouTube to show the videos to more people. And see you next time.